and gentlemen, for our last live demonstration of today, we are pleased to welcome back Roctool. Roctool will highlight innovative molding processes such as heated patterns, showcasing a mix of high performance and energy savings. Please give a very warm welcome to Mathieu Boulanger, the CEO, and Edouard Philippe, the Composite Business Development Manager of Roctool. Gentlemen, the demonstration floor is yours.
Thank you, Joanna. Good afternoon, everybody. My name is Matt. Edouard also will be presenting, and Hugo over there at the machine is one of our engineers, part of the Roctool engineering team here, based in Europe. So a few words about us. We're a technology provider. We provide heat and cool solutions using induction heating. And this year, for the show, we decided to come up with a new approach, a new system that we've been working on the last couple of years, which is a heated platen. We used to integrate our technology only in molds to have a heat and cool per mold, per part. Here it's a heat platen that allows you to have a dynamic heating and cooling system, and you can place inserts directly on your tool based on your parts and so on, which means that during the show we're showing different kind of inserts, different kind of parts, different kind of materials. During the whole JEC, we will be showing woven material, non-woven material, chopped carbon, flax. And right now, for that particular demonstration, we have discussed, and one of our customers, Saint-Gobain Aerospace, they're combining their technology and our technology, I think, to something really unique. And we're excited to share that with you right now. So before we share the story about their material and so on, let us present what we have over there, and I will let Edouard show you the machine and to show you a little bit about what we have.
Thank you, Matt. So in front of you, you have a compression molding equipment with our new technology, Roctool Induction Dynamic Saver, RIDS. So simply, it's a very dynamic heating platen with the integration of induction heating and water cooling circuit. And so you have the possibility to use different mold insert on the top of the heat platen with aluminum or steel insert. With this new technology, we have our different equipment on the right. So for this installation, we use induction generators, which is a DZ 50 kilowatt, and different cooling unit that we use during the demo live.
So on that particular, and we can start Hugo to crank. We will explain. So for that demonstration, we will explain as we're heating. Hugo is going to place the material, and we will explain as we're heating what is the material and what we're showing. But just a few words about the heat platen. We've got an induction generator that can split power on the top and on the bottom. So we split the power in two sections, so 2 times 50 kilowatts. We use all the power when we're heating up, but once we reach the temperature we need, we have the ability to dwell. We can keep temperature, hold, or between cycle, we can get to a lower temperature, but not back to ambient. We're not going to reheat everything back and forth, but we will cool down just the insert to be able to demold. The platen, ready for the next cycle, will remain fairly hot. And that is quite interesting in terms of energy consumption, because the dwell, if you have a 100 kilowatts to heat up everything, once you're there and once you dwell, you're using 5 to 10 kilowatts to keep your platen hot. Think about it if you have to do that with oil heating or electrical cartridges. Okay, it would be quite difficult. So here we're in the heating stage. So you can see on the remote on the screen here, you can see the temperature rising as we have the two zones. So we're already 200 Celsius right now. And gradually the heat will transfer to the platen and then to the inserts. And we're going to go to 250, I think, 250 C, 240 C. Okay, that's how hot to heat the platen and then the insert. So as we're preparing, a few words about Saint-Gobain. Saint-Gobain is a manufacturer. They manufacture composite parts in thermoset and thermoplastics. And when we came across, it was like very good technology combination because they can tailor and 3D knit, so 3D knitting, fiber and plastics together at the shape of the application you have. So what happens is, think about the droppability inside the tool, how sometimes it's difficult when you have woven material, sharp corners, to avoid wrinkles, to avoid all kind of issues as you place the material in the tool. Here, this is coming, as you can see, it's a soft, almost like a sock, like a preform, and that's done by the 3D knitting machine. So when you place it in the tool, and obviously here, we have a much bigger part, the advantage is that you can decide the kind of reinforcements and where you want to have it. If you want a carbon section, fiberglass, if you want all carbon on one side, glass on the other, you have the ability to do that. So for us, as a technology provider to do heat and cool, it's great because we can just put this easy preform, not have to worry about how it's going to be placed inside the tool. So going back to the technology itself, the heat platen is controlled with thermocouples. We have a PID system. So the temperature you see there is the temperature of the platen. It's not the temperature of a heating device that tells you that hopefully you're getting temperature. And then you can combine with thermocouples within the inserts on your mold surface to know what's the temperature for your material. And in this case, it's polycarbonate, and to make sure you're reaching the right temperature. Okay? So if we look from one cycle to another one, here during the show, we cannot do production, okay? It's just demonstration, so we cannot do 20 parts in a row. But think about how easy it would be. You heat up your platen, you heat up your inserts, and then you just have to cool down your inserts and slightly cool down your platen, and then you dwell, and then you reboost by induction to get back to your molding temperature, cycle after cycle. So, Edouard, in terms of cycle time here, can you tell us the different steps?
Yeah, for the moment, so temperature reach 240 degrees in less than 3 minutes. And we know we are on the dual time. So we stabilize the temperature during 1 minute before to start the cooling.
Okay. So obviously this is a small part, okay? But if you had to do that tiny part, right? And you want to use a woven material, how would you do it? So that's to show the 3D knitting capability in this case. We're showing also some shoe soles with chopped carbon. We're using flax and polypropylene. A heated platen like this is so versatile that you don't have limitation whatever you're molding, because you always have the right temperature in the inserts to mold the material. Another one here with this 3D knit technology is, you can see, this is knitted on a plaque, and then by induction, we molded a complete plaque. You can see 3 different reinforcements within the same part.
Now we start the cooling. So for the cooling, we use a dedicated cooling unit, which is a C6 equipment. This equipment can be delivered 100 liters per minute at 20 degrees. And we have a dedicated manifold to have a regular water circuit on the platen and to reduce quickly the temperature.
In terms of size, the biggest platen we made so far for a customer early summer last year was about 2.5 meter by 1.5 meter. Okay, so that's how far we've been so far. But we don't have a limitation per se. It's more about the business case. If you really need to go high heat on large surfaces, we will outperform oil and electrical cartridge. There's no debate, because of the ability of induction being fast and having a dwell at low energy consumption. So the platen temperature, I think, will remain fairly hot, a little less than 200. And right now, we're bringing the insert to demolding temperature, which I think is about 80, 70 C. and then we can hand the part, and you can see how the part behave.
Just again, few seconds. We are at 130 degrees.
A few words about before we make the platen or before we make a mold. We have 2D and 3D thermal analysis. Our engineering team, what they do is they can simulate temperature distribution based on how much power you're using, how many kilowatts you're going to be using for the dimension of the part. And we check where to locate our induction inside the mold or inside the platen to make sure we reach the temperature with a good temperature distribution. So all of this is done prior to actually making the mold.
Again, a few seconds before to open the press.
Same thing for the inserts. Right now we're using aluminum inserts in the tool to be molding, but we could use steel inserts. As long as it's in good contact with the heat platen, there's a good energy transfer. There's no issues.
Let's go.
Okay.
So we are reached demolding temperature, so now we can open the press. And so we see the part is consolidated on the bottom of the mold. And just quickly, we demold the part.
So actually the application, because we have multiple demonstration, I think tomorrow we're doing like this piece. It's a coaster with chopped carbon, recycled carbon. We do the full compression, so it's very, very stiff. And this one that we do with Saint-Gobain, we place it on it, oops, sorry, like this. And then it's for my desk, because I never have something, and we do that. That's the little thing for the desk. That's for composite geeks. But I think that was smart for our engineering team. That's the beauty of demolding during a demonstration.
Wait a minute again.
It's okay, no problem. We know what's composite. So in terms of the thermoset side of things, because all the show we do thermoplastics, we decided to do that, but we supply heat platen with the ability to heat cool, so it's also compatible, obviously, for thermoset processing. Anybody doing prepregs or snap curing epoxy, I mean, we have the ability to heat cool, so it's not, it's compatible. We got lucky, all the demos today. What's happening? The part doesn't want to come out. At least we know it's consolidated.
Allez.
I have the ones we made before, 20 minutes ago, because we always prepare one part. I can pass it around. I mean, you can see, and actually the deep section, if you didn't have a 3D knitting, you wouldn't be able to mold it with just a composite fabric.
Wait again, few seconds. We have some issue to demold the part, but
well, we can
live demo.
We can take some questions the time we pick up this part from the mold. If there are any about the heating technology.
That's good.
That was a tough one.
So that's a final part.
Thank you. So it's the same. So that's that's it. I mean, we're going to run another round, obviously, and any questions or comments or that you might have. Here are some of the examples of other reinforcements that we're doing on, like we said, we're molding non-woven, we're molding chopped carbon. The ability to heat and cool just becomes a lot easier to mold composites, obviously. Go ahead, sir. Sorry, I don't hear.
Check.
What was the total cycle time?
Cycle time here. Are you including when Hugo struggled to pick up the part or not? Because if you're doing this is... You did not, okay. So at the show, we're doing about 6 minutes, okay, with a little bit better cooling, because the cooling here, we get what we get. We would be around 5 minutes.
We hit, in this configuration, we reach a heating ramp around 55 degrees per minute and around 60 degrees per minute for the cooling time.
Here's just the example of a 100% recycled carbon as non-woven with pre-impregnation of I think it's polypropylene in this case, and how you can just transform it just by a 5-minute cycle time, and using a small aluminum insert, so very cheap mold, using the heated platen.
Any other questions?
That's the problem about the 5-minute cycle time, because they say we have 30 minutes, so we have 25 minutes to talk about stuff. No, but it's true. If we were doing infusion, right, or a good old thermoset, we would have a couple hours to wait for the part. So
That's good. But
Can you tell us what are the key advantages of this new technology?
So if we have to summarize, I would say flexibility in the production environment, having the ability of having a temperature from low temperature to very high heat. Those heated platens can go to 400 Celsius plus. So that's quite something. Number two, I would say energy consumption. You're going to cut by 2, by 3 the energy that you would be consuming if you had electrical heating or oil. Especially when you're not molding, a lot of manufacturers, they don't turn off. They keep it hot for the next batch of production for tomorrow because it takes too much time to reheat the press or, and so on. So in this case, you're using induction when you're molding. When you're not molding, everything is off. And I would say number 3, the surface quality. The ability to have a good high heat molding as you rise temperature in thermoplastic. The viscosity of the resin drops. You get a resin-rich surface that will cover all the fibers if it's non-woven or woven. That's also a nice advantage using the induction.
Okay, thank you. And one more question. Can you explain why you chose this demonstration?
So I think we were known, I mean, for those who know us, to have the tools equipped by induction and not the heated platen. So we came up with this new approach for whoever doesn't want to have dedicated heating tools, just make inserts and put the mold on a heated device. So that's why we came up with this, this new dynamic saver, which then anybody with a press machine wants to kind of boost their press with a new capability, they can do so without having to research some high heat integration and so on. The induction will be able to be added on an existing press.
Okay, thank you so much, Mathieu and Edouard, for your demonstration this afternoon. They will be back again tomorrow morning at 10 a.m. And if you would like to continue the discussions, please don't hesitate to visit them at their stand, which is located right next door to us. And I'm sure they would love to continue to talk to you. Ladies and gentlemen, this concludes the live demonstration area for today. So once again, don't hesitate to come back and join us tomorrow at 10 a.m. We will be here for another 2 days, and you will be able to see all the intricate processes and revolutionary technologies that are at the forefront of composite manufacturing. Many thanks again for today's wonderful demonstrations from Roctool, from MVP, Thermwood, and Aerovac Composites 1. And we wish you a fantastic afternoon at the show, ladies and gentlemen.
Thank you.
Thank you.
Thank you, everybody.